The National Basketball Association is one of the four major North American sports leagues, and it is where the best level of basketball in the world is played. There are 30 teams that each compete every year for the Larry O'Brien Trophy and to be crowned basketball champion of the world. In the 21st century, NBA teams have taken to using analytics to improve their chances of winning games. They have entire departments that use statistical analysis, trends, and other numbers relevant to the game to determine how they should play and in what areas they need to improve. For example, the Toronto Raptors hired over 10 statistical analysis staff such as Eric Curry, who played in NCAA basketball and has a knowledge of the game, to head their analytics department. The question that will be examined through this study is, how does a team's pace of play affect their success over the course of a season? Two interesting variables when it comes to NBA teams in analytics is possessions per game and points scored per game. The hypothesis is that the more possessions a team has per game, the more points they will score. These two variables will have a moderate positive correlation. To win basketball games in the NBA and be basketball champion of the world, it is essential that teams get used to playing new age basketball and increase the pace of the game to have a better chance of winning games. The two variables being looked at are possessions per game and points per game. A possession is defined as every time a member of one team has the ball in their possession and either shoots or commits a turnover. Possessions per game are the total amount of possessions any player on the team has combined and averaged over the course of a season. Possessions per game are indicative of how fast a team plays. The faster you come down the court and shoot, the more times you can have the ball. Logically, it makes sense that as the amount of time a team has the ball in its hands, the more points it will score. This variable is the explanatory variable, and it is discrete because the variable does not depend on the outcome of another, but instead impacts the outcome of another variable. Also, the variable can take any value. The population of interest is every basketball team in the world, and the sample population is every team that plays in the NBA, from 2014 to 2017. The data is continuous because it can take any value such as a decimal. A point is every time the basketball goes into the net. This can be done with a free throw, field goal, or three-pointer. Points per game is the average amount of points a team has per game over the course of one season. Points per game are indicative of a team's success. The more points a team scores per game puts them in a better position to win. Points per game is the dependent variable in this situation because the number of points a team has per game is directly dependent on the amount of possessions they have per game. Since a possession either ends in a shot or turnover, teams need possessions to score. For example, a team with only one possession could have a maximum of only one score. The sources used to find the data were the franchise indexes for each team from Basketball Reference and the NBA. Variable number 1, possessions per game. Looking at the histogram, we can see there are no true gaps in the data, which means that the data evenly spread out. The range of the data set is 14.2. This number was found by subtracting the max value 107.9 and the minimum value 93.7. The range is not really indicative of the spread of data. The range is quite large, which would indicate that there are some gaps in the data. The reason for the range being so large is there are some outliers that increase the range by a lot. The histogram has normal distribution and a narrow curve. This is because most of the data is centered around the peak of the data, around 100 possessions per game. Also, the outliers on each side cancel each other out. For example, the outliers on the far right of the box and whisker plot, around 104 possessions per game, are due to the Golden State Warriors, who invented the style of fast play. Another way it is justifiable that the histogram has an even curve and even distribution is the mean and median. The mean is the mathematical average, which can sometimes be skewed by outliers, but the fact that the median is the same proves the mean has not been skewed by any outliers. This is because the median is the physical middle, so it is really not skewed by any outliers. The standard deviation for all the data points for possession per game is 2.68. This means that the data is not very spread out and most points are very close to the mean, therefore making the mean very accurate. The standard deviation being so small also makes sense since there are no gaps in the data. Most data points are close to the mean and the outliers are not incredibly far outside the majority of the data. The semi-interquartile range is 3.3, which is found by subtracting Q3 from Q1, which is 101.5 minus 98.2. This number indicates how close the data is in the middle set in between Q3 and Q1. 3.3 possessions per game in a small semi-quartile range shows how close the data is together in the middle of this data set. The fact that the SIQR is so small once again shows how accurate the mean is, and we can see the data is close together in the box and whisker plot. Lastly, the semi-interquartile range being so small makes sense graphically because the data points in the center of the box and whisker plot are close together. We can see they are close together because there are over 120 data points. On the histogram, the moderate curve and the high frequency around the middle of the graph makes sense. The best measure of spread is the SIQR. This is because the SIQR being so small shows how close together the data is in the middle and as seen in the box and whisker plot. The range and spread are quite large, which would indicate the data is very spread out when it's really not. The SIQR is perfect because it shows the data is close in the center, and it does not include the variables on the outside that skew the standard deviation. Variable number 2, points per game. Analyzing the histogram, we can see there are no gaps in the data, just as well as possessions per game. The data is evenly spread out and has normal distribution with a narrow bell curve. The range of data is 26.2 points per game. This number was found by subtracting the max value, which is 118.1, minus 91.9, which is the minimum value. The range is very large, but it is not really indicative of the spread of data. The range is quite large, which would indicate that there are some gaps in the data and that the data is very spread apart. The reason for the range being so large is that there are outliers that increase the range by a lot. The two highest frequencies are on right beside the peak in the histogram. There are some real outliers because the data is mostly around the center of the data, and on each side of the mean there is almost an even amount of outliers on each side, so the data does not skew the mean. But there are more outliers closer to the higher end of the graph. For example, the outliers on the far right of the box and whisker plot, around 118 points per game, are due to the teams that have the best players in the league and focus on offense first, because they have the players with the best skills and their strategies to use their pure talent to outscore other teams. Examples of teams like this that apply this principle are the Houston Rockets, with perennial all-star James Harden, who's considered by most the most prolific scorer in the NBA right now. The standard deviation for the data collected for points per game is 4.82. This means that the majority of the data on average is somewhat spread out, so on average the data is slightly off from the mean. The standard deviation being moderate is expected because the measures of central tendency were not exactly the same, and there are slightly more outliers on the far right of the data. The semi-interquartile range is 5.6 points per game. The SIQR is found by subtracting Q3 from Q1, which is 105.8 minus 100.2 in this case. This number indicates how close the data is in the middle set in between Q3 and Q1. 5.6 is a medium to small semi-interquartile range, and it shows how close the data is together in the middle of the data set. The fact that the SIQR is so moderate reinforces the accuracy of the mean, and we can see the data is close together in the box and whisker plot. The best measure of spread is the standard deviation. This is because the standard deviation, not being small and not being incredibly large, shows how moderately spread the data is together over the whole set. The two-variable analysis. When analyzing the scatter plot that compares possessions per game and points per game, it is evident that there is a positive moderate correlation. I can see this graphically because most of the data points are close to the line of best fit. I can also see this using the correlation coefficient, which is 0.60. And as seen in the above table, on the scale to judge the strength of correlation coefficient, 0.6 is considered a moderate relationship. The best regression model to represent the two-variable graph is a linear model. For the most part of the data resembles a linear graph. The equation of the line of best fit, which is points per game equals 1.08, possessions per game 4.6. There are several different reasons for the visible outliers seen on the graph. There are teams like the Toronto Raptors who have always played very well when they play slower and excel from a slower pace. Teams from 2014 to 2016 are outliers for the points that play slower, but still score a high amount of points, when the fast style of play was not used by many. Lastly, the teams like the Golden State, Houston, and Philadelphia are for teams who have mastered playing at a very fast pace, and in turn have a very high amount of possessions and points per game. The relevance of this is very important. The sport of basketball has greatly evolved since the beginning of the sport. Players today are more exponentially athletic and have far better skills than the players in the beginning. Players like Russell Westbrook and Stephen Curry are changing the way basketball is played before our very eyes. Kids growing up today will grow up thinking that their style of play is the correct way to play. Never before have point guards had the blurring speed and kangaroo-like leaping ability of Russell Westbrook, or the dizzying dribbling ability and infinite shooting range as Stephen Curry. The same evolution has taken place in basketball for team concepts. Teams today are taking advantage of that athleticism and are relying on the three-point shot more and fast breaks. According to Bleacher Report, the fastest team during the 1996-1997 NBA season had 95.34 possessions per game. The slowest team in the 2017-2018 NBA season had 97.84 possessions per game. This is a clear example of how teams in the NBA have also adapted their strategies and are trying to play faster to perform better. One expert says that the estimated number of possessions per game is higher than it's been since 1989. It's more of an up-and-down game built on speed and quick decisions. This has created a debate among traditionalist and new-age basketball minds. Does playing faster basketball lead to more points? Teams that want to have success in the modern NBA need to play faster to keep up with teams that are using that style of play to their advantage. The first issue with the data I collected could be when players come down the court and try to play fast when that is not really their strong suit. They tend to rush a shot. Most often, a rush shot does not end up in points. This ends up inflating the number of possessions but not really ending up in points. For example, teams like the LA Clippers have amazing players that flourish in the fast break with their speed and jumping ability, like DeAndre Jordan. But he does not have the skill set to excel in the half-court game. To be able to thrive in the half-court game, you need to have great technical skills and basketball IQ. Players in the NBA like DeAndre Jordan are great athletes but do not have the technical skills to flourish in a slower pace. So although they have more possessions, it does not always equate to more points. Also, the teams in the data that never play a slow style of pace are outliers. Some teams play much better when they play faster and very rarely ever take their time on offense. These teams are outliers within the data because they are not capable of playing the half-court game. Therefore, all they do is play fast. But to benefit from playing faster, you also need to change the pace to keep your opponent on their toes. So a team that only plays fast cannot really get more points just from playing faster. Great examples of teams that strictly play fast are the Phoenix Suns. Another issue with the data could be any bias by one of the websites I use to find the data. The website Basketball Reference is run by private individuals and there's no way to assure the accuracy of the statistics recorded and updated. If the creators of the website have any vested interest in any of the teams or could benefit from altered statistics in any way, the statistics may have been altered. There's a positive, moderate, linear relationship. The causation of the data is a cause and effect because a change in the independent variable causes a change in the dependent variable. It is simple. The more possessions, the more chances you have to score. Therefore, more possessions leads to more points. This is backed up by the correlation coefficient, which is quite high. The data collected was for the past 4 years only. If you collected the possessions per game and points per game data since the beginning of the NBA, the correlation coefficient would surely be stronger. The limitation of the data would be that this relationship does not apply to all basketball teams in the world, just the teams in the NBA. This is due to the fact that the NBA has the highest caliber basketball players in the world. The only possible survey bias is if the website that collected the data changed numbers or copied numbers incorrectly from the NBA's database. A great extension from possessions per game and points per game would be seeing the win percentage of teams that play faster. We know there is a relationship between teams scoring more than when they play faster, but does that translate into more wins? Or is the teams that play more faster get more fatigued and in turn do not play well defensively? By changing the measure of success from points per game to wins per game, it is possible to develop a better understanding of how a team's technical skills result in success.